Hi, everyone. Thank you all for coming. My name's Kumar Venkateswar. I will shortly be joined by Rahul Subramaniam, who is the CEO of Dev Factory. I'm excited to talk about one of what I think is the most exciting feature of all of our SageMaker launches, although I love all of them, SageMaker Autopilot. So what I thought I would start out with is a bit of an introduction for what we thought about when we created SageMaker and how that led into the creation of SageMaker Autopilot. And then we can go into the details of how SageMaker Autopilot allows you to scale machine learning, which has been the objective of SageMaker from the very beginning. And then Rahul will join me on stage and talk about how Dev Factory uses ML in order to scale their efforts and how they can scale their efforts with SageMaker. And then I'll conclude with a demo of SageMaker Autopilot so you can get an idea of how that can be used in order to achieve the objectives. And then we'll conclude from there. We should have some time at the end for a few questions. So the context in which we thought about SageMaker and the context in which we are thinking about Autopilot and all of the announcements that we've made is that we face this new fundamental challenge. There's a huge growth in data, and it's assisted by the fact that there is easy storage and easy compute in the AWS cloud, among other things. And because of that, there's this massive increase in the amount of data. Unfortunately, there isn't a massive increase in population in order to keep up with the data, which the result of that means that people end up getting overwhelmed. Or, in this case, most of the data is untapped. And our customers have basically reached out to us and said, we need something in order to help use this data and to help our efforts to scale. So if you think about that problem and you say, machine learning is the way that you can scale your efforts. It enables customers to learn human expertise in a scalable way and then apply that to this massive influx of data. So human beings can scale their expertise and to be able to take on this massive data challenge without increasing the number of people that are working on these problems. And one example of that, I have one customer who deals with a lot of visual data. And what they said was, in order to deal with the influx of visual data that's coming in, they'd probably need to hire something on the order of 8 million people in order to deal with that data. And that's just crazy. I mean, there's no company that you can't even organize in such a way that you can deal with 8 million people. On the other hand, you also look at machine learning, and if you say, I'm going to apply machine learning to this problem, you also can't hire, to throw a number out there, we'll say 80,000 data scientists. Because you go from 8 million, and you can say that these data scientists are able to help people scale their efforts, and you need 80,000 data scientists in order to create that model. You can't hire 80,000 data scientists either. So what do you need to do in order to take advantage of machine learning and tear down these barriers? So the first thing that we saw is a barrier to even getting started with machine learning is that machine learning was pretty hard. It's hard to set up the environments. It's hard to train. I mean, this slide is one of the things that we showed and we thought about when we thought about SageMaker. How do we make it so that you can take this scalable environment and apply it to all aspects of machine learning, from building an environment in which you can explore the data to training up your model and being able to create this optimal model for machine learning, and then deploying it in an environment so it can be used in real-world applications. And by creating a set of components and a service that you can use around this, and you can standardize on things that are standard and focus on the things that are unique to a particular project, you're now able to scale those data scientists' efforts and make life much easier The example that really speaks to me is one of our early adopters was Intuit, and they've been able to go from 6 months for every model iteration to under a week on their model iterations, which means that they've been able to accelerate this process through. However, we also have some operational challenges as you get into this realm of being able to scale up into higher and higher numbers of models and to be able to take on more and more challenges. Because initially, when you think about this infrastructure, you have to be able to have a data scientist who's involved in every aspect of going through this machine learning cycle. So it needs iteration. It needs iteration because it's statistical, things can drift over time. So if you look at things like the SageMaker Model Monitor, we're trying to look at things like that and automate some of those processes. Some of the other challenges that people have are machine learning needs critical data, and there are a number of non-standard tool sets. There are a number of tool sets that initially come up. When we launched SageMaker, PyTorch wasn't really something that was demanded by our customers. And that happened last year, and we were able to incorporate in PyTorch as part of the solution that we offer. But we see this all the time. One of the announcements we made was DGL, Deep Graph Library, was one of the things that we would incorporate into SageMaker. So you need an environment in which you can adapt and add in these tool sets over time. The third challenge that you have is that it's computationally expensive. So you need to be able to say that for certain problems, I'm going to have to scale up my compute in order to come to a solution, and I need to do this in a way that I can experiment with. So maybe this will work, maybe this won't work. If I have to go out and buy a large amount of compute, that's not going to work, because what if the experiment fails? So you need the agility that having this compute environment that is elastic will let you have so that you can take on these computational problems. And of course, now you want to automate this whole thing, because you run into this 80,000 data scientist problem. You can't hire data scientists fast enough. No one can hire data scientists fast enough. So you need as many people as possible to be involved in this process, and you need to make it as easy as possible so that you're able to apply machine learning in all of the places where you have a lot of data. So the customers that we had that started out with machine learning, what they found now, and we've learned this from our customers because they've gone from the paradigm of training single models into a paradigm of they now have tens, some even have hundreds of models. So we started out with, we need to make it easier to start out with machine learning. And we continued on to try and demystify machine learning to make it accessible to a larger audience. But the third thing we need to do is we need to make it easier to scale. So I think of these as three fundamental challenges to scaling machine learning. And scaling machine learning, you can't basically say, we're going to multiply everything in order to go to tens of models. I'm going to have 10 times as many people, 10 times as much compute. It doesn't really work well that way. So our goal with all of these announcements, and this is the context in which SageMaker Autopilot was introduced, our goal is to help you scale. So we want people to be able to bring together these multiple tools in a single interface so that they don't have to tool switch, so that the data scientist workflow is efficient. And the result of that was we created SageMaker Studio. We wanted to make sure that teams were able to collaborate to work together better. And the result of that was we created SageMaker notebooks with collaboration features so that people could collaborate together better. We created debugger and model monitor so that those parts of the processes, the training process as well as the deployment process, we could make sure that those are not driven by a data scientist manually going through and searching for those problems. Instead, It's the system tells the data scientist, hey, something's wrong, you need to look at it. Hey, this training isn't progressing the way it should. Hey, there's a change in the environment, maybe you should go and look at it. And of course, last but not least, it's how do you get started in an efficient way and start out with a large number of model candidates. So instead of I'm going to go through and train every model candidate and select every model candidate one by one, I'm going to have this array of model candidates that I can choose from and use that in order to more efficiently drive my machine learning process. And that was the result, was SageMaker Autopilot. The process of creating these models is pretty hard and iterative. There are a ton of combinations. If you start out with, I'm going to think about what kinds of preprocessors that I can apply. I'm going to look at various different algorithms, and then I'm going to sweep through the entire hyperparameter space that's associated with those algorithms. You quickly end up with this massive combinatorial problem that you can't possibly put enough effort to in order to be able to explore the entire space. So what we saw our customers ending up doing was they said, let's choose a portion of the space that we think we can explore. Let's fix on certain algorithms or certain frameworks or certain specific things that we feel comfortable with. Because once we fix those things, then we can explore other parts of it that may be useful. So we saw, prior to automatic model tuning, we saw customers wouldn't even do hyperparameter tuning. They would say, let's just pick linear models, and let's just go with what we have, and we'll apply it towards the use cases where we have models that are good enough, and then when we have time, we'll come back to it, and maybe we'll do deep learning. So you end up with, I'm going to address some of the use cases, not all of them. I'm going to settle for models that are not as good, maybe, in order to be able to make that problem tractable. So in response, the first thing we did was we created automatic model tuning. We started with that, and we said, we need to be able to make hyperparameter tuning really easy as it is to train a model. So that way, for something like XGBoost, which has a large number of hyperparameters, you'd be able to sweep through the entire hyperparameter space in an efficient way instead of saying, well, you know, maybe I'll do grid search or random search and try and explore some of the space. But instead, I'm not going to settle. I'm going to try and do automatic model tuning. So instead of grid or random search, what we said we would do is we will try and find a good solution that optimizes both model quality as well as cost. And we settled on Bayesian optimization in order to provide high-quality model tuning. We build a surrogate model based on the trials that were performed, and then we decide based on the trials which part of the hyperparameter space to explore. And this provides all of our customers with a way to balance not only clock time and compute time with cost. So that way they can come out with a high-quality model in a reasonable period of time at low cost. And then what happened was customers said, hey, wait a second. This hyperparameter tuning is great, but that's not the whole problem. We need help in all of the other areas. I mean, you've given us a great solution for hyperparameter tuning. Automatic model tuning works great. It gives us high-quality models. But at the same time, we're not sure whether we're using the right instance type for our compute. We're not sure whether we're using the right preprocessors. And we're still not exploring all of the rich set of algorithms that SageMaker has to offer because we just don't have time to sweep through all of these things. And we don't even know. Like, AWS has a number of instance types, and SageMaker supports a number of instance types. Maybe M5.12x large is the best instance type, or maybe it's 4x large, but we don't know because we don't have the ability to be able to sweep through all of these choices. So the other thing that customers faced was there is this dichotomy that people faced between do-it-yourself model training, where they choose everything and they control everything. We had model tuning, which helps. But they also saw that there are a number of AutoML solutions out there. And they said, well, these are fine, but they look like black boxes. And I'm not sure that I'm learning the right things in order to make better models over time. And the other thing is, some of these AutoML solutions, they look like toys, because they don't have super fine controls. My experts look at them and they say, well, you know, that AutoML solution, that's for a non-expert. That's maybe for a developer. It's not for a data scientist. Or then a developer or more complicated solutions look like they're more targeted towards a data science doing things like hyperparameter optimization, but they don't look like they're something that's friendly to developers. So customers looked at this and they said, well, it looks like I have this choice that I have to make. Am I going to pick this do-it-yourself solution and put my data scientist on it, and I can do that only for the most critical of my machine learning problems, the ones that are most important to my business? Or I can find this AutoML solution and I can say, well, you know, product manager, you're going to do lead scoring, but here's your AutoML solution. It may work, it may not work, but at least it gets you further. So in their minds, they said, well, we see this false choice, or we see this choice that we have to make between these two solutions, and I also need help with this do-it-yourself, where I have to go through and I have to make these choices about instance type and preprocessing and so on. So what we said was, let's try and take those and come up with a solution that solves those problems. We want fully automatic model tuning. That is something where if you want to use it as a fully automatic solution, it will work as a fully automatic solution and you don't need to dig in. But if you want to dig in, the details are there. And then we also want to make it so that you have demystifying machine learning is one of our goals. And we want to make it so that you can understand what's going on under the hood so that you can learn over time. It's not just, I want this black box solution and I want it to be done. It's, we want to help you through with learning how to do machine learning, and those developers that are interested in learning more about machine learning and creating machine learning solutions and building solutions for more and more problems, that they have the ability to look into what's going on and learn more and build better solutions over time. Also, we wanted people to be able to take those artifacts because we don't want this black box. We want to demystify machine learning. We want to make it easy to start. We also wanted to make it so that you have this artifact that you can use for, particularly in regulated industries. The feedback that we were getting, especially as we were developing the solution, was, I'm in a regulated industry, and there's no way I can use an AutoML solution. Because if I go to regulators and I tell them, this model was created through this AutoML solution, I can't tell you anything more about it, but it's AutoML. The regulators are going to be like, what am I supposed to do with this? How can I evaluate whether you followed the right process, and how can I go back and understand whether there are aspects of that process that were not adhering to the regulations? So we wanted to make it so that you had this artifact that let you have the visibility into understanding the process by which you arrived at a model. So the solution was, let's automate machine learning and provide the requisite visibility and control. So first of all, we need a simple experience. You specify a prediction target. It performs this operation on tabular data. And we decided tabular data was the right place to start because a lot of businesses, a lot of our customers work with a large amount of tabular data. If you look at things like spreadsheets, if you look at things like databases, We had an announcement last week about integration of some of our database services with SageMaker. We see that these are important sources of data that are critical to the business, so we need to provide a solution that works with that type of data. So the most common problems that we see on that type of data are classification and regression. So we started out with, let's work with tabular data, work with classification and regression, and then let's go through the entire process by which you go from data to feature engineering through to algorithm selection and hyperparameter optimization. And then let's make sure to provide the amount of visibility that you need in order to learn from it, understand it, to be able to provide the kinds of things that auditors need in order to understand the process. And of course, because we wanted to provide all of this in a single interface that you can use to understand all of the other aspects of machine learning as well, we wanted to integrate it together with SageMaker Studio. So how does it work? First of all, it goes through and analyzes your data set, calculates statistics, and you then have the understanding of instance type, preprocessing, and the algorithm. The second, it provides you with a commented notebook describing the choices that you make. And that way, data scientists can provide their input into the process if necessary. And then we train and tune the model pipelines that are the result of that in parallel in order to create the optimal combination of preprocessor, algorithm, and hyperparameters. So if you look at it, it's pretty simple to get started. This is the Studio interface to Autopilot, and we see the only things that you really need to specify are input data, output path, and the experiment name, along with the target column that you use that you want to predict. And it will automatically select your problem type, whether you need to do binary classification, multi-class classification, or regression. There are certainly cases in which it's really hard to tell the difference between multi-class classification and regression. This is something that really is a difficult machine learning problem to solve. So in those cases, the Autopilot system will actually ask. It'll return you with a message that says, well, I couldn't figure it out automatically. Could you tell me whether it was multi-class classification or regression? But in most cases, it actually automatically selects the problem type. And of course, it's not just targeted towards making it easier to get started with machine learning. So as a result, we also have a similar Python interface in order to be able to use that through all of the normal interfaces through Jupyter Notebooks. It has APIs in the AWS SDK, which means that you can automate through that process and you can link it together with all of the other goodness of AWS services. So let's take a quick look at the data exploration notebook as well. So one really important thing that we wanted to make sure that was possible was that we had an opportunity to educate people about exactly the choices that Autopilot was making along the way as well. So we have these description of the data, the kinds of things that it understood in the data, and the data that it used in order to generate these candidate pipelines. So you can see it's things like characteristics of the data set that were input, what the target column name is, various aspects like that, what the problem type detected was. So that way, not only can you go through and you can understand what was understood about the data, but for someone who's learning machine learning, especially a developer that's learning machine learning, they can go through and understand more about the process by which you can yield good machine learning models. And we think this is super important because it's not just, it's not magic. you actually need to make sure that you have good data all along the way. You need to make sure that the data sources are good, that the pre-processing is also good enough to be able to discern some of these features, as well as all the way along the way, which means that your Autopilot solution isn't working in isolation. It works with all of the upstream things as well, which means that we need to make sure that the person who's looking at this understands the things that they can do in order to make a better model. So if you look at that, we also provide suggestions as well as available knobs that can be adjusted in order to make a better machine learning model. So it's not a black box at all. It's something that you can use as an educational tool to learn about your data, as well as to make better machine learning models. So then we look at the candidate generation notebook, and the candidate generation notebook is structured in the same kind of way. It has a bunch of automatic choices, and you can go through and you can execute those automatic choices as is, or you can execute them one at a time, and you can see what happens. You can say, well, what happens if I select a compute instance instead of a general purpose instance? Is that something that makes a difference to my training time? So the practitioner has an opportunity to be able to adjust the process as they go along the way. So if we look underneath the hood, you can see that you start out with this tabular data source, and then we have we introduced a new type of job in SageMaker called a processing job. And we use these processing jobs in order to auto-generate these notebooks. Both the data exploration notebook and the candidate notebook are generated through these processing jobs. And you can optionally look at the candidate notebook, or you can choose to not do that. And then the result of that, if you choose to execute through, then the result of that is a set of trials. And each of those trials, in a fashion that is similar to the way that we did hyperparameter tuning, it picks a set of candidates first, and it uses the results of those candidates in order to choose the next set of candidates. So we see that you can go from a single set of data to a set of 7 to 10 different trials that are executed, and then the result of that is a set of 250, up to 250 candidates that can be used in order to generate the optimal model from that set of candidates. But the other thing is, supposing that accuracy or the objective function that you choose is not your only goal. And that's true in a lot of real-world situations. It's not just accuracy. If you have an accurate model and you have a case where you want to deploy it onto a device, if that accurate model is too big to fit in memory on the device, it doesn't matter how accurate it is, you can't put it on the device. Or supposing you have a latency-sensitive use case, for instance, if you're performing product recommendations. And we have Intuit is one example of a customer of ours that does product recommendations. If they're not able to generate the product recommendations in time, it doesn't matter how good those recommendations are. It can't show up in the interface because a slow interface is not acceptable for any type of interactive application. So there are trade-offs that are more complicated than just, I want to pick the best model. It's, I want to pick the best model that is subject to these business constraints that I have to make sure are fulfilled as part of the process. So for those cases, it's important to not only have the best model at your disposal, but also the set of best models among which you can choose whether it's the best one for this particular use case or not. In other words, model training involves trade-offs. So in this case, you can see that if I look and if I took the top candidate in this particular case, it's a pretty sizable model. It's 9 meg. It's not huge, but the latency of 450 milliseconds is probably unacceptable for any interactive application. So assuming that it's targeted towards an interactive application, someone will look at that latency and say, 450 milliseconds is just right out. I can't take that model in spite of the fact that it's the most accurate model among the set that I had. Instead, I'm going to take model number 2, which at 200 milliseconds is still kind of slow, but it's OK. I can choose that one, and maybe for my particular application, I can live with that. On the other hand, if I had really tight latency constraints or tighter latency constraints than that, I could pick model number 4, which has only 50 milliseconds of latency. But as a practitioner, I get to make those choices because in spite of the fact that it's an automated machine learning system, it allows me enough visibility that I can make the trade-offs that my business needs. So for a more real-world look at the way this is useful, I'd like to hand it over to my friend Rahul.
Thank you, Kumar. So I'm going to start with a quick introduction of DevFactory. So DevFactory is the innovation and development arm of the Trilogy Group of companies. We have over 100 companies and products in our portfolio. And for the most part, these are products that were written anywhere from 10 to 20 years ago. So they are old school, monolithic, on-prem products for the most part. Okay. So as the name suggests, DevFactory, what we do is we try and identify standard patterns of operation and churn out outcomes like a factory. And with every one of these patterns, we look to add value for our customers and for the business. So about a year ago, we created this pattern where we said we were going to take the data that is in all these on-prem systems for our customers, try and get it into the AWS cloud storage, and then go do interesting and exciting things with that data that would add tremendous value to our customers. So some examples of the kind of value we started adding was, to start with, we looked at the data and we said, OK, what if we used something like AppSync and Amplify and created a simple mobile app for our customers where the field agents would, for the first time, have access to the data in their systems, even in offline mode. Now, trying to create that kind of a solution with an on-prem deployment of a product was almost impossible. But suddenly, you opened up so many new opportunities. The second, very interesting solution we were able to build by taking the data to the cloud was to use the S3 Athena QuickSight stack and build BI capabilities, which were extremely complex to go build for every one of the 100+ products that we have in our portfolio, right? But here there's a pattern that we could just keep stamping out with every one of our products. The most exciting one, though, of these was to be able to leverage the data that was now sitting in S3 or any other data store like Aurora, and be able to then apply the Glue, the data catalog, and SageMaker stack to create really interesting ML-based insights, which were unthinkable for our customers. So imagine these are customers of old products that were dying, sitting on-prem, and suddenly by getting the data out, you were able to do some very, very exciting things with these products. So I'm going to walk you through some of these solutions that we've built, and just to give you a flavor for how we've been able to add tremendous value to our customers. So the first one I'm going to talk about is ZephyrTel. So ZephyrTel is our fast-growing portfolio of telco-specific products. And when we talk to our telco customers, these are mostly tier 2 and tier 3 telcos. When we talk to them, the two most important problems that they are trying to solve as part of their business is lowering the TCO for their deployments, and the second one is preventing churn. Okay? So churn arguably is one of the most important problems that these telcos face, especially in the prepaid segment, okay? Now, historically, the way these telcos have been, trying to solve the churn problem is to do churn detection. So they have information about their customers, and then when they realize, oh, this customer has had no activity for a while, they kind of realize the customer has probably churned. The problem with that is at this point, if they try to bring this customer back to their network, it costs 5 times more because at this point it is a customer acquisition problem. Your customer has already left the network, right? And it's not customer retention anymore. And that process costs 5x more than just retaining your customer. So we were able to look at all of the data, from various different sources. We had over 40 vectors that were used to create these models where we were doing prediction, trying to predict which customers are likely to leave the network because of the experience that they were having, with support or the kinds of calls that they were making, whether their usage patterns changed in any way. We were then able to predict a customer's likelihood of leaving the network over the 30-day period. Now, this is incredibly valuable to these tier 2 and tier 3 telcos because they are now able to go take this data and go create very targeted campaigns at these customers and retain them instead of detecting them once they've already left, right? So they can completely change the customer experience that they can offer to their customers, okay? The second problem was specifically around campaigning. Now, I gave you one segmentation, which was very churn-specific segmentation, where you create a segment of customers that are likely to churn. But segmentation in general is one of the biggest problems with, telco customer data. You want to find the right set of customers to go target for very specific promotions, campaigns, or figure out a way to upsell them to improve your ARPU, okay? So we were able to create 2 kinds of models with the data. One that was centered around what we call the RFM analysis, the recency, frequency, or monetary value of the transaction. So this is all transaction-based. How recent your transactions were, how frequently those were executed, and what is the value, the monetary value of those transactions. And so there's one class of segmentation that is based on that, which is incredibly valuable to the marketing groups of these telcos. They are able to then go target the right set of customers with specific campaigns. The other one was very specific to usage. How much data do you use? How frequently do you use the services? And when during the day do you use these services? Based on that, the rate plans, for example, can be significantly more optimized to not only give customers better value, from their spend standpoint, but at the same time, protect and improve our telco customers' ARPUs as well, okay? So that's incredible value that was, enabled for us because we were able to use the SageMaker platform to do this. Now, had we tried to do this process without SageMaker, it would have been insanely expensive and really, really complicated. But with all the tools available in SageMaker for us, we were able to actually do this in a matter of about 8 to 10 weeks, which is quite remarkable. The next one I want to talk about is our Ignite portfolio, where we've been working on 2 very interesting solutions. The first product that we have, that we worked on is called Sensage. This is basically an event data store. That's an on-prem event data store that's used to collect event data and log data from large system deployments for some very large enterprises. And what we did with Sensage was to take all of this event data and create a very exciting intrusion and anomaly detection model. And this is, from a security and compliance standpoint, is a very, very exciting proposition for our customers, where historically they had a rule-based system where they would, detect a security breach or an anomaly, and then they would start writing rules for it. But obviously, rule-based systems can't cope with the variety of attack vectors that you see these days. And just to give you some data points, so in this particular model, we had an accuracy of about 94%, which basically means that, a precision of 94%, which basically means that for every 100 attacks that we saw, every 100 attacks that we were predicting, less than 6 of these were actually false positives. And then we had a recall of 95%, which basically means that for every 100 attacks, fewer than 5 actually went undetected. Okay? So that was very exciting to us. But the other really interesting thing about the machine learning models was that out of 10 new kinds of attacks that we had the system exposed to, the system adapted and detected 6 out of those 10. So there's no rule-based system that could have possibly detected that, but the fact that we introduced machine learning models for intrusion and anomaly detection, we were able to capture over 60% of completely new, unseen attacks. So it's super exciting for our customers there. The next product that I want to talk about is Gensim G2. This is basically an application development platform for process and production control expert systems. And this product is used in extremely large factory installations, very, very large cement factories, very big utility installations. And what they have there is they have lots of sensors that constantly send data up to the G2 platform. And the expert systems basically analyze the sensor data. The app that is written up then produces appropriate outcomes that then feed back into the system. So what we did was we actually took all the sensor data. We took all the output that we were getting from the expert system, and we were able to use that data to, number one, create a model that we could then call the digital twin. So if you guys are familiar with digital twins, it's basically a virtual model of what your system is supposed to do. And because we had all this data and we had an expert system that would actually spit out certain behavior, we were able to just create a machine learning model for that. Now, what became even more interesting was we were then able to take the sensor data that was coming in, and historically we looked at all the incidents of machine breakdown, and we were then able to train a model to predict machinery breakdown. So there were certain things that you would start observing very early on before a machine actually broke down. And for these large utilities and large factories, unexpected breakdowns are extraordinarily expensive. So the ability to actually have the sensor data come in and be able to predict the behavior and breakdowns of this machinery was incredibly valuable to our customers. So just by taking this data to the cloud, using SageMaker to create these models, just unlocked so much more value for our customers over here. And one more example that I wanted to bring up was the example of the smart lead solution that we have. So for a lot of our automotive customers, what we do is we actually buy leads, we score them, and give them to our customers, which are automotive OEMs. Now, the interesting one, where this one is different from the other examples that I gave you, was we have had a machine learning model in this particular case for many, many years. And it's been fairly effective. But we had 3 fundamental problems. Number one was the models that we had were built with decades of automotive experience. We literally had folks who were in automotive marketing, who had 20, 30 years of experience, who would come and sit with our data scientists and go figure out, based on gut, fine-tuning parameters for what kind of model to go create. Second, there were lots of data massaging activities that were done that were based on intuition, not on real data underlying it. And our models would start going out of whack very quickly. The third one was that the entire model training and retraining process was extremely expensive, and they would be few and far between. And that started becoming a big problem as well. So once we switched everything over to SageMaker, in a matter of a week, we were able to recreate better performance of the models from scratch, starting from scratch. So we were able to create much better performance of these models, much better outcomes, and at the same time, our costs reduced dramatically. We had an additional challenge in that when a lead comes to us, we have kind of first right to reject a lead or buy it, but we have to make that decision in less than 100 milliseconds. Historically, we've had to build a lot of engineering and infrastructure to kind of be able to answer those questions in that kind of latency. But with SageMaker, we are currently getting somewhere around 30 milliseconds latency on making a decision on a lead without adding any infrastructure, without adding any new engineering to the process. So for us, from an efficiency standpoint, this was a use case where we added a huge amount of value in terms of being able to retrain the models more frequently, being able to produce much better outcomes on our lead scoring, on our lead scores. And at the end of the day, our customers who buy these leads or get them from us are the ones who benefit because the close rates on these particular leads are significantly higher. Okay? So last, I'm just going to leave you with this, which is the Amazon SageMaker suite is actually a remarkable tool that you should really give a serious consideration if you have data. Figure out a way to get your data into the cloud and start doing that. You'll be able to create amazing value. All you have to figure out is what questions do you want to ask. And we couldn't be more excited to have Autopilot and the SageMaker Studio announced. We are building our machine learning factory for hundreds of products that we have in our portfolio. And like Kumar just said, we need to scale up our approach to doing this. So we couldn't be more excited to have Autopilot now in our factory. And we are going to be building out an amazing new ML factory within Dev Factory. Thank you.
So I thought I would take an opportunity to close out with a little short demo of what it is that you can do with SageMaker Autopilot and what it looks like. So if you look at creating an experiment in the SageMaker Studio environment, you can create this Autopilot experiment simply by specifying an experiment name, providing the location of the input data, your target attribute name. So essentially, you want to be able to specify the thing that you want to predict, and then the location for the output data. And literally, these are the only things that you have to specify as part of the machine learning process, which means that it's pretty simple. I did want to kind of scroll down and show you a bit of the other options that you would need to specify. In this particular case, the problem type is automatic. But you also have the opportunity to say, you can run the complete experiment and run it end-to-end on Autopilot, or you can choose to just generate the candidate generation notebooks and the data exploration notebooks so that you can have more control over the entire process. And if you look at advanced settings, these are essentially security settings, but that's about it. That's what you use in order to create an experiment. And given the amount of time that we have, I was going to switch over and just show you what the flavor of what those results look like. So essentially, you start out with this set of candidates that were generated, some of which would have pretty early on would have relatively poor performance. And over time, if you look at it, the models get better and better. And then if you look at it by objective metric, you can see that there are a number of candidates that have different pre-processing settings and different algorithms that you would be able to use in order to achieve your business objectives. The other thing I wanted to kind of flip over and show you guys is the data exploration notebook. It not only talks about the type of information that was within the training data set, but it also shows you a sample and gives you a set of suggested action items that you could use in order to make sure that your data is producing good machine learning models. So you can see if you look at this particular data set, the banking data set that is typically used as part of these examples, you can see that if there are mismatches between the data and the column headers, that you would be able to see that with this random set of data. You would be able to look at the governance if you have missing values in a particular column. And you can also look at some basic statistics about it. So the result of that is you know more about the data set, and you know the things that you would need to correct in order to produce a good machine learning model as a result of it. And very similarly, if you look at the Autopilot candidate notebook, it not only tells you something about the environment in which this candidate notebook needs to be run, so the various versions of software that are important as a result of that, but it also tells you exactly which configurations of algorithms and hardware that are needed in order to run that. And it also provides you with a set of suggestions if you are looking to tweak the performance of that notebook. So for an expert practitioner, they have the freedom to be able to adjust that in order to produce better models and hand-tuned models in addition to a novice practitioner that can just run this whole thing on autopilot. So with that, I'd like to conclude with kind of a recap of what we talked about. We looked at how we can scale that machine learning process, and we looked at how Autopilot is an integral part of being able to handle that deluge of data that's coming in and replace that to be able to scale out your data science efforts in order to address those problems. And my friend Rahul talked about how Dev Factory is using this in order to achieve their business goals. And we had a bit of a demo. And with that, I'd like to conclude and have an opportunity for you guys to ask any questions that you like. Thank you very much.